Welcome to section 8.1. Today we're going to multiply and divide rational expressions. Some previous knowledge that you're going to need. Factoring is going to be huge in this lesson. We're going to use the difference of squares, the AC method, and pulling out the GCF. I have also attached several videos that highlight these three things. So if this is something you're having difficulty with, definitely check out those videos before you proceed to this video. The second thing we're going to do is we're going to be multiplying and dividing fractions. So we're going to have to remember what are some of our rules on that. And then our exponent rules are also going to be big in this. So again, if these are things that you think you're having difficulty with and you start this video and you're not really sure what to do or how I got to certain points, you'll want to stop and you'll want to review those methods of factoring and fractions as well as exponent rules before you begin or get too deep into this lesson. Here's kind of the types of problems that we're going to see. And what we're going to be doing is we're going to be taking these expressions and we're going to be simplifying them, meaning we're going to write them in an easier way, something that is a little less complex. And we're going to be multiplying certain fractions and we're going to be canceling things out. We're also going to be dividing some fractions, so we're going to have to remember that we multiply and then we take these two and we flip that fraction. Some certain strategies that we're going to use to solve. The first one being, we're always going to look for the GCF. If there's one thing that you are sure to do every single time is find the GCF and pull it out. That's always your first step of factoring. If it can be factored, we always want to factor it every single time. We want to always make it and put it in parentheses and just make it separate from everything else. We want to rewrite these expressions in the factored form. And the last part, parentheses around each expression. And you're going to see that I'm going to point that out a lot. It keeps everything separate and it kind of keeps everything in order. The first example we're going to look at is a fraction, and notice the form of it. It has parentheses. We call each of these a separate term or a separate factor. So our first step is we always pull the GCF out. If we look at the top, there is no greatest common factor. So there's nothing that they both have that we could pull out. The bottom also does not have a GCF. So we immediately go to our next step, which is factor things if we can. The difference of squares says that x squared minus 1 can be factored into x minus 1 and x plus 1. So instead of this term, now we have this. And I'm just going to take this and I'm going to rewrite it to the right side. Notice I'm keeping everything in parentheses to keep everything separate. So I take that and I factor it and I continue on with the process. At this point, only things that are factors, so only things in parentheses, can cancel with other things in parentheses on the top and bottom. For instance, x minus 5 is in parentheses. X minus 5 is in parentheses down here. We cancel it. We say that these both become 1s because x minus 5 divided by x minus 5 is 1. Nothing else can cancel. So on the top we have 2x. And on the bottom we have x minus 1, x plus 1. And this form is completely acceptable. This is actually the route that we want to keep this problem in when we have it solved out. So you notice nothing else can be factored and nothing else can be canceled. And we actually, if you want to leave that top 2x in parentheses, you can definitely do it like that too. Our ultimate goal here is to factor things and then find what is on top and what is on bottom, what matches, and those always go away because we're dividing by that. Our second example. Notice the very first thing we always do is we take out that greatest common factor. So on the top, we look for things that they both have. The greatest thing that they both have is a z squared. So I'm just going to pull that out. I'm going to say z squared, and when I do, I have w minus 1. On the bottom, I can take out a z to the third. When I do, I have 1 minus w. At this point, we have these terms, and I actually want to keep these in parentheses as well whenever I factor it out because I know that those are separate factors. Whenever I cancel things, this z squared over z to the third, this one becomes 1, and this bottom one becomes z to the first because there's one more down there. At this point, if you see w minus 1 and 1 minus w, they're in opposite orders. The w's on the left here and it's on the right here. So the order is reversed. What we want to do is we want to pull out a negative 1. So the z is still on the bottom. I'm going to factor out a negative 1 from this portion. When I do, I end up with w minus 1. And you'll see if I factored that back in, this would become negative w, this would become plus 1, which is the exact same as this bottom. I still have w minus 1 on the top. And the reason that I did this is because now it's written in a way that we know that these two will go away. So this becomes 1, and this becomes 1. So our final answer, we have 1 on top. We still have our factors on the bottom. If you want to leave it like this, that is quite all right. You can take it one more step and say this is like 1 over negative z. But both of these answers I would consider correct. This negative 1 is a tricky concept. You'll always want to check for it, especially if you look at these two and you say, wow, those are really close. Those are really close together. Let's see what we can do to manipulate it to get it to be something that we want. The next example is a multiplication problem. On this multiplication problem, we're going to be multiplying straight across because that's what we do on fractions. So what I'm going to do is I'm going to take this top and I'm going to rewrite it as multiplication. Notice all of these are multiplying. It's 4 times a times 15 times b squared. On the bottom, I'm going to do 5 times it's b to the first times b to the first, which is b squared. And then a squared times a squared is a to the fourth. And then I'm not going to forget about the 16 here. At this point, what I would do is I would say, what are factors? Factors are things that are multiplied together. So at this point, I'm just going to separate them by parentheses. I'm going to say each of these is a factor. The reason being is factors you can cancel with the top and the bottom. If it's not in parentheses, if that's not something that you can reduce, then you cannot reduce it. In this case, though, we have certain factors that can reduce. The first thing that jumps out to me is 4 and 16. 4 divided by 4 is 1. 16 divided by 4 is 4. I see 2b squareds. That becomes 1. A over a to the fourth, a becomes 1. A to the fourth becomes a to the third. And I would recommend writing this down below so you are completely aware of where you're at. 5 and 15 becomes a 3 on the top and a 1 on the bottom. From this point, I'm going to go ahead and simplify further. By multiplying my numbers straight across, I have 1 times 1 times 3 times 1. So I end up with 3. And on the bottom, I have 1 times a to the third times 4, which is 4a to the third. I look at my final answer and nothing else can simplify, so I know that I'm finished. My next example is a polynomial over a polynomial. What I'm going to do here is I'm just going to say this is a factor of itself, so I'm just putting them in parentheses. From here, if I have a polynomial, I want to try to factor it. And remember, if you're having difficulty with the AC method or the difference of squares, you need to watch those videos and really get caught up and really solidify that before you move on. If you can factor these, they're very simple problems. So I'm going to go ahead and just factor this. It is x minus 2 and x plus 4. And the bottom factors into x plus 3 and x plus 1. So at this point, my problem now looks like this. Now I have things that I can look to cancel. At this point, none of these terms on the top match the bottom, and none of the terms on the bottom match the top. So on this is kind of step 1 of a more complex problem that you will see on example 4b. So all we've done is we factored it and see if anything matches. If it does match, we cancel out. If not, we do not. What I'm going to do is I'm going to take that information from the last slide, the factoring, and I'm going to add it to this problem. Now that I've already factored that, I also want to say x minus 2 is a factor because it is on the bottom of the fraction. 3x plus 3 is also a factor. I'm going to go ahead and factor out that greatest common factor, which is 3, and now it's x plus 1. So at this point, if I rewrite this using all of my factors, because remember, instead of this piece right here, we now have it factored in a different form. We have and it's multiplying straight across. So now we have this, and we can cancel out things that match. So remember, we put everything in parentheses, and then we factor it, and we also keep those factors in parentheses. So here I see an x plus 1 and an x plus 1. Those two go away. I also see an x minus 2 and x minus 2. Those two match, they go away. Everything else is going to stay the same, and I'm actually just going to keep it in that factored form because this is going to help you when you move on to higher math classes like college algebra. They'll want it in this form because you're going to do certain things at the top and bottom to work further into a problem like this. So our steps, we factor, we multiply straight across, and we look for things that match. Our next problem, the only difference from the previous problems is its division. So I'm just going to rewrite it as multiplication, just like we would any other fraction. And when we do multiplication, we flip the second fraction. So if you're not familiar with that, again, watch those videos. The next step we do is we factor it out. So I'm just going to quickly factor these. So instead of a squared minus 9, I have a minus 3 and a plus 3. And on the bottom, instead of a squared plus a minus 12, I will have a minus 3 and a plus 4. So I no longer have this bottom. I've rewritten it like this. Now remember, I had these two factors. And if you want to save a step here, you can look at all the tops because you know you're going to end up putting those all next to each other. And you can look at that compared to the bottom and see which ones on the top match which ones on the bottom. So the first thing that I see is an a minus 3 and an a minus 3. I know that those two go away and they both become 1s. And then if I look for other things that might cancel, I see an a plus 3 on the bottom and an a plus 3 on the top. Those become 1s. And now on the top I have a plus 2, and on the bottom I have a plus 4, which would be my solution. And if you want, you can keep those in parentheses to allow yourself to fully know that we cannot cancel anything else. It's important to note that this a and a cannot cancel because here they are certain factors. They are stuck in that factor. When we look at complex fractions, we want to consider the top and we want to consider the bottom as individual pieces. So what I'm going to do is I'm just going to think about this and think about what this fraction means. Another way to say this fraction is division. So I'm just going to take this problem and I'm going to rewrite it as a division problem. It's going to be the top, and that's going to be divided by the bottom. And now we make it look like something that is very familiar to us. So it is division, so we want to take that and we want to make it multiplication. When we do, we have to flip the fraction. And again, I would start off by just putting those guys in parentheses because you know that they're factors, and we're going to rewrite the first term. When we do, I would go ahead and put parentheses around those as well. When we factor this, we get r minus 5s, and it's r minus 5s, rather plus, sorry, difference of squares there. So now when we look to see top and bottom, what things go together, we have an r squared and an r. This becomes 1. This becomes just an r. And then down here, again, we see, relating back to one of those original examples, things that are very close. 5s minus r and r minus 5s. So we want to take this and we want to factor out a negative 1. And when we do, we get 5s minus r. And I'm just going to rewrite this second term as is. So now I can see that what cancels. 5s minus r and 5s minus r cancels. And we are left with r over negative 1 and r minus 5s on the bottom. At this point, I want you to complete the additional problems, and I want you to log those into the spreadsheet, into the Google form that is attached right below this video.